Go for solving for an unknown variable here. In this question, we have essentially a left side and a right side of the equation. And in order to really solve for when we have x's that are going to be to the power of 2, so I'm kind of looking ahead. We haven't expanded or anything, but it looks like, if you remember our expansion, it looks like we're going to end up with an x to the power of 2, which is like a quadratic of some kind. Our goal eventually is going to be to get all the terms on one side of the equation and probably set them equal to 0 or something like that. Okay? So what we can try here is we can actually go through the process of expanding this. We'll expand it and then try to collect like terms and see if that puts us in a better position to solve this. So if you remember, on our left side here, essentially to expand this, we're just going to multiply the bracket by itself. And then we're going to duplicate that exactly on the right side. Do you want to help me out as we go through it? Do you remember this process?
Not exactly. Can you go over it?
Yeah, absolutely. So we take the first term in the first set of brackets and we're going to multiply it by both. And then we're going to take the second term in the first set of brackets and multiply it by both. So I'll quickly jump through the x squared, 2x times 2x will give us 4x squared. And then 2x times 3 gives us 6x. Same idea, 3 times 2x will give us 6x, and then 3 times 3 gives us 9. Okay, so we're set up here. On the right side, similar idea again. We end up with 1 times negative 4. Oh, I apologize, that's the wrong number there. 1 times negative 4 will give negative 4x. And 1 times 1, I should have done that one first, sorry, is 1. Negative 4 times 1 is negative 4x again. And negative 4 times negative 4 is positive 16x squared. Okay, what we're going to do next is Paige will get a little squished here, but we're going to take everything from the right side of this equation, so all of these terms, and we're just going to move them to the left. And all that's going to be is this will become positive, this will become negative, this will become positive, and this will become negative. And that'll allow us to put them together and kind of collect like terms as we go through this. So when we do that, I'll leave the left side stuff over here farthest to the left, so 4x squared plus 6x plus 6x. And I could have collected those two like terms. And then we get positive 4x, negative 1, positive 4x, and then negative 16x squared. And we're left with that 0 we talked about. Okay? Now, this is a little daunting. There's quite a few terms here. But very quickly, we can see that 4x squared and negative 16x squared, those are like terms. So we can collect those. We can collect our 6x, positive 4, and positive 4. And finally, we can collect 9 and negative 1. So when we do that, negative 16 and 4, that's going to give us negative 12x squared. Our 6x, positive 4x, and positive 4x, that's going to be 20. So when we add that, we get positive 20x. And finally, 9 and negative 1 will give us just 8. So we're left with 8. Now this question, it has a negative in the front. So there's a couple ways we can go through this one. We can see if we can make it a perfect square trinomial, because that was part of your factorization. We can also quickly check to see if we can find factors really quickly of it. Right off the bat, we could divide by 12. That'll give us like a fraction in the middle. It's a little difficult to work with. And if you remember your factoring there, you can get up with terms. If we're looking for like two numbers that multiply to whatever A and C are. But in this case, we're looking at, what is that going to be, like 92? No, 96. We're getting some big terms. So maybe we're going to try that factorization that you guys had done before. Okay, so for factorization, we're trying to turn this into a perfect square trinomial. That's going to be our goal. So I'm going to add another page here, and we'll bring it over. It was negative 12x squared plus 20x plus 8. Okay, so this is that tricky part. What we're going to do here is we're going to actually move the constant back to the other side. And the constant is just the term that doesn't have a variable attached to it. We're going to move it to the other side, and we're going to find a new constant here. So when we do that, we'll get negative 12x squared plus 20x is equal to negative 8. If you remember, what we want to do is we want to get this a value kind of back down to 1. So we can divide everything by negative 12 in this case.
Yeah.
What that's going to do is that's going to turn this into just positive x. This will become negative, and we can reduce that fraction. If you look at it, 4 goes into both those terms. So it can actually be written as 5 over 3x. And then over here, this can also be reduced. 4 goes into both of those. It'll be positive 2 over 3. Okay, so we have 2 sets of fractions. What we want to do is we want to try to make a perfect square trinomial. And if you remember that, a perfect square trinomial is something that looks like this. It ends up with 3 terms where there's an a squared plus 2 times a times b plus whatever b squared is. So we're trying to find a b squared in this case. So we kind of have to break down our middle term here. Our middle term, we know that the a for this term here is already 1. So because that's 1, we know that this number is going to be 1. So that kind of simplifies what we're looking for our third term. Because that middle term is 1, we actually just have 2b. Okay, so we want to solve for b, and we know that 2b is equal to this value here. So we can actually build our own little equation on the side, negative 5 over 3. And we got to isolate for this b term. Because whatever that b term is, we're going to square it, and that's going to be this term that we plug in to make a perfect square trinomial. So to isolate for b on the right, we would divide both sides by 2. Okay. Now it looks a little funny dividing by a fraction, but there's a really quick trick to it. All you have to do is multiply the denominator, which is 3 in this case, by the number 2. And then that's done. You've actually done your division. So this just becomes negative 5 over 6. So we're done with that. So that's our b term. But remember, we're looking for b squared. Okay, so this is really similar to when we were doing completing the square. That was that b divided by 2 squared. Oh, that's dragging a little. That's what we're trying to find here. We've taken that b term and we're putting it through this process. So when I square this, it's actually going to become positive, right? And we're going to get 25 over 36. So on the left side of the equation, we have x squared minus 5 over 3. And then we're going to add 25 over 36 to both sides of the equation. That's what's going to allow this to be balanced here. So I'll write it in red. Positive 25 over 36 is equal to, this was 2 over 3. And again, positive 25 over 36. What we've done on the left side is we've created a perfect square trinomial. And all that, I forgot an x in the middle there. All that means is we can factor this really simply. We find the square root of the first and the last term, and we already know the square root of the last term is the middle term here. So it's written as x. We take the negative, and then 5 over, sorry, I shouldn't say the middle term, it's 6. That's the term we wrote here. Negative 5 over 6 squared. And then we just got to simplify this side here. And this is where we're going to get that like type of radical answer you saw in your work there. I need this to be a common denominator. So 3 times 12 will actually work. So I'm going to multiply both these by 12 and add. So we'll have a denominator of 36. 2 times 12 is 24. 24 plus 25 is 49. Okay. Oh, this one actually works out really nicely. They've clearly built this one with a purpose. I'm going to jump to the next page just for a little bit of room. Remember, we have x minus 5 over 6 squared is equal to 49 over 36. So this is one that works out really nicely because what we want to do now is we want to isolate for x. We essentially only have one x on the left side. So we're going to square root both sides of the equation here. When we do that, this 2 and the square root drop off and we're left with just x minus 5 over 6. While over here, we're going to get plus or minus. And what's neat is this fraction, you can actually square root both the top and bottom term. The square root of 49 is just 7. And the square root of 36 is just 6. This plus or minus tells us that we just have 2 answers. And all we have to do is bring this fraction over to finally figure out what the answer is. So we have x is equal to positive 5 over 6. And I'm going to leave it in red because that's just indicating that there are technically two answers to this. You could break it into this. You could say x is equal to 5 over 6 plus 7 over 6, or x is equal to 5 over 6 minus 7 over 6. And because the denominators are already the same, this one actually works out really nice. It's 12 over 6, which is equal to 2. And in this one, we end up with negative 2 over 6, which is equal to negative 1 over 3. So that's quite a few pages of work just to find one little piece of information. But we did a lot. We expanded, we factorized, all starting at this one interesting little case here.